Kia ora. Applications of nonlinear simultaneous equations. Example. The height of a tomato plant after it is first planted increases each day. The height in centimetres, h, is related to the time in days t. Here are two possible models for this relationship. Model 1. The height is equal to 100t plus 80, all divided by t plus 10. Or Model 2. The height is equal to 2t plus 8. A. Which model has a hyperbola for its graph? So to answer this, we'd have a look at the graphs, and probably by deduction you'd see that the correct answer is Model 1, hugely because there's a variable t on the bottom line there. B. Which kind of graph does the other model have? So hopefully when you look at that you can recognise a y equals mx plus c format, so that means that would be a straight line. C. Which model gives the more sensible result after a long period of time, and what is this result? So the way to answer a question like this is to imagine substituting a really large number, or doing that on your calculator for t. So what I've written here is if you imagine substituting in infinity, 100 times infinity plus 80, the 80 would be insignificant compared to the 100 times infinity. So it's kind of like the top line would just be 100 times infinity. On the bottom line, infinity plus 10, well, the 10 is insignificant. So it's kind of like just like looking at infinity. So you've got 100 infinity, all divided by infinity. There's the infinity on the top and bottom line will cancel. So that means you just be left with 100, or 100 centimetres. For Model 2, on the other hand, if you substitute in infinity, you'd get 2 times infinity plus 8. Well, the 8 wouldn't make a difference, but 2 times infinity would be a ridiculously large height for a tomato plant. Therefore, Model 1, the hyperbola, gives the more sensible result for a long period of time, which is 100 centimetres. D. Which model gives the greater height after 50 days? By how much does this exceed the measurement given by the other model? So what we can do there is just substitute in t equals 50. And when we do that, we should get that it's 84 2/3 centimetres for Model 1. Into Model 2, substituting in t equals 50, we should get 108 centimetres. So therefore, Model 2 exceeds the measurement given by Model 1, and the difference is going to be 108 minus 84 2/3, which is 23 1/3 centimetres. E. Solve the equation for the two models simultaneously. So that means setting them equal to each other. So I've just put equation 2 is equal to equation 1 there. So how would we look to solve that? We would multiply the denominator t plus 10 up onto the left-hand side, just to get rid of that fraction, because remember we hate fractions. Next step, expand out those brackets, then gathering our like terms. So when we do that, we should find that we end up with 2t squared minus 72t equals 0. So there's a common factor in there of 2. Divide through. That gives us t squared minus 36t equals 0. Common factor of t we could factorise out. So that means if this equals 0, either t equals 0 days or t equals 36 days. F. Explain fully the meaning of the solutions to part E in this situation. Well, the two models gave the same height initially, so when t was equal to 0 days, and again after 36 days. Okay, so what I want you to do now is to try some of these questions on page 478, exercise 29.04, just starting with question 1, then 3, then 5. Good luck.